anyone tell me what do you mean by latching and unlatching? Do you know
Madam,
latch?
hold the output signal, madam.
Yes, to store some particular, to store a one bit of data, we'll use latch. Okay. So the latch and flip-flops are a basic memory devices which we use in our digital electronics in the processor and also. The basic memory unit is nothing but a flip-flop. Okay. So the previous version of a flip-flop is nothing but a latch, which is used to store a one bit of data. Okay. Now same, that concept is used in the PLC to hold the input value. Okay. To store that input value in the output continuously. Okay. So it will be holding the previous data. Okay. That is called latching. Now, what is unlatching? Can anyone tell? Guys, can anyone tell what do you mean by unlatching?
Don't know, madam.
So, breaking the latch is nothing but unlatching. Okay. So, what is the best example we can use for latching and unlatching?
Giving a output as input
Giving the output as input.
for
Okay.
that.
No, example, best example, not the how we exactly do it in the ladder diagram. Where exactly this latching and unlatching will come into picture.
Push button, ma'am.
Yes, whenever we are using push button. Okay, so whenever we are using latching and unlatching, there one more concept come into picture is nothing but the memories. Okay, so in every PLC there are two type of memories we'll be using. One is a one bit memory, okay, to store the input and output conditions, okay, high or low state, okay. And the one other memory is it's a 32-bit memory where we'll be storing all our mathematic operation or any numerical values or alphanumerical values if you want to store. We'll go for this 32-bit memory type, or if you want to store only input and output conditions, then we'll go for one bit memory type. Okay, one is data memory and one more is a bit memory. Okay, so in Omron PLC, the address for bit memory is 10.002 to 10.255. Okay, this is a bit memory. One more is the data memory. So we'll address it as D0 to D255. Okay, so now one second. So yesterday we were solving this problem, right? Guys?
Yes, ma'am.
Yes, madam.
Okay, now this is a classical example for latching and unlatching. Okay, so now here we can see this is a push button. Let's imagine the K0 is a motor. Okay, now since I'm using a push button, whenever I give a press, only that time the output will be on. Whenever I release my finger, the output will be off state. If I use a push button to operate a motor, will it be efficient? Will motor
No.
function? No, right? So to overcome that, whenever we are using a push button, to overcome that, what we'll do, we know that the outputs are nothing but a storing element. It will be storing a condition of input, either high or low, taking that high condition parallel to the input switch. Okay, the whatever input switch we are using, will be connecting a parallel NO contact to that by giving the output address. Now, this K0 is storing the previous data. Okay. Now, it will not store the present data. It will be always storing a previous data. So now, let's say now this switch is in, one second. Now, this switch is in 0 state. Here also, output will also 0. Now, since I'm using the same address I'm giving here, that means now this address has a value of 0. Okay. Now, this address contains a value of 0. Now, this will also is giving a 0 signal. Here also, it is giving a 0 signal. Let me on this one. Okay. So, when I make it on, this push button is allowing the current to flow to the output by making this output on. That means 1. Okay. Now this 1 will be, since I am using this address K0, the address has a value of 1 that will be stored in the K0 again. Now this is getting on. Now this is giving a high signal. Okay. There is a millisecond of gap between, there's a millisecond difference in this process. Okay. But we can't see it. Now I'll again make it off. Okay, when I make it off, this is giving 0, but here I have given 1. This is a previous condition. This will be giving 1. So now this becomes 1. Now this 0 will go again here. Okay, when it passes a 0 signal, again it will give a 1 signal here. So because of which it will remain continuously on. Okay, now this process is nothing but latching. Now, I can't keep any output or any output device continuously on. So I need to make it off also. But if I use only this switch, I cannot make it off. Therefore, to off this output device or break this connection, I am going to use one more switch. Okay. So one more push button I'll be using, but I'll be using it through a NC contact. Okay. Whenever I press this button, this will break this signal, the latching signal, thereby making the output 0. So now this switch, whatever we are using to break it, is called unlatching. Okay. So now, whenever we connect any switch in parallel, making the output continuously on is called latching, and breaking that continuous signal is called unlatching. And here we can tell this connection as a sticky switch. Okay. Any doubts? Is it fine? Is it okay?
Okay, madam.
So understood, this is called latching and unlatching. Okay, let us realize this one in the CX programmer. So I am taking a push button. I'll name it as PB1. Then I'll take a output. So let's consider this as a motor. Now I am latching it. So by considering the output again. Okay, now this is latching. So if I use another push button, Okay, let's simulate this one. So now when I make it on, the output is on. Let me switch it off. Sorry. So even if I switch it off, the output is continuously on. Since I'm using a NC contact, this second push button is not affecting the output. Now I'll make this switch again on. So even now the output is continuously on. Okay. Now if I make the other push button on, the latch will break and output will become off. Okay. So this is how we execute. Now let's say we have a limited number of inputs and outputs. Okay. Let's say we have a requirement of 4 outputs. Okay. And our PLC is supporting only 4. So let's say I want to store every switching condition. Okay. That time we'll go for the memories. Okay. So it is a good habit to store the input switching, like whenever we write our program for any projects. So there normally we'll be using push buttons. Okay. To store the start and stop condition in a memory, it's a good habit. So whenever we write a program, we'll store the input switching condition in the memory. Then we'll be using the memory address in our whole program. Okay. And the speciality of this memory address is that we can use the same address at the input side also, output side also. Okay. There is it will not tell that it is repeated or something like that. Okay. So now what I'll do, I'll change this output to a memory. Okay. So I'll take the second switching condition in the other. So and I will store it in one more memory. So now I'll use this memory address for unlatching. Now I'll simply take the memory addresses instead of taking directly switches. Okay. So this is how we can use the memory addresses. Okay. Any confusions? Guys, are you there? Is it okay?
Ma'am, one second, ma'am, repeat.
Okay. See, whenever we have a limited number of inputs and outputs, and we need to use the multiple conditions, multiple signal, or we need to store multiple signals. That time, what we do, we go for a memory addresses. Okay, we'll store the every input condition in memory address, and then we'll be using that memory address to activate it. Okay. Now here in this program, you can see here. Okay, wait a minute. Okay, see, now what I'm doing here is that this is a latching process. Okay, now this latching, I am storing it in one memory bit, and this another second, the stop push button condition, I'm storing it in another memory. So to execute that, whatever the requirement I have into the program, to my program, to operate the output, I'll not directly use the input switches. I'll go with this memory addresses. Okay. So now this memory addresses can be used as inputs as well as output. Okay. Got it? These are just storing one bit of data. Any confusions? Till guys, are you there?
Yes, madam.
Got it? Any
Up to
confusion?
what time they will be latching, madam? You can.
Please,
1 second, I'll show. Can you please off your mic?
ma'am, how did you execute memory at input side, ma'am? Ma'am, how did you execute memory address in input side?
I have used here, see the input addresses. Wait, I'll run and I'll show. Sushant, your voice was completely breaking. Please drop a message, okay? So that I can understand what was your problem. Now, let me on this one. So now I have switched on, okay? So this memory address, what is there? You can't see it physically, okay? It is internally stored, the 10 and 10.1, okay? Now don't see this last rung. Now what I have done, I am storing this input condition in the memory 10.0 continuously through latching, okay? Now what I'm doing, I am using the second condition. When I make it on, I am storing the second condition in another memory. Okay. So now these two conditions are continuously storing. Whenever I operate on the switch, the memory will be getting operated. Through memory, I am accessing the output. Okay. So whenever I act on the memory will act upon the output. Okay. Until the program is on, till that time, the output will be on. Input address remain the same. It is from 10.002 to 10.255, 10.255. Okay. So you can repeat it both in input side and output side. See, for the whenever we take a PLC, there is a different input address and there is different output address. Whereas for the memories, it is a fixed memory, like it is one particular memory address. That address can be repeated in the input side as well as the output side. Now, we'll tell that, right? Whenever we are writing the PLC program, the input address cannot be repeated at the output side. Okay, here we can repeat them. Okay, the same address will hold it. Okay, and the output address can be repeated at the input side. Okay, understood? How can we get that INQ in the address bits in the page? They are not displaying. What INQ page you want to see, Srinivas? Guys, is it okay? Clear?
Okay.
Are you talking about this window, Srinivas?
No, madam. Just like that, I 0.00. It right left side I displaying, madam. 0.00.
Can you please share me the pic, what you're getting? In your system, it is not displaying. It is only displaying 0.00.
Yes, madam.
Oh, that's fine. No problem. That depends on
No
the
problem.
software. Okay.
Okay.
Any other doubt? It's okay. Is it okay? Fine.
Ma'am, you are using here 10.00 as memory address for 1 bit memory.
For Omron PLC, it is 10.00 is the memory addresses.
Yeah, ma'am, for 32-bit memory, how
That is
D,
D0. That D0 will come whenever you are using arithmetic operation, shift operation. Okay, that time it will come, not here. Now see, I cannot use D0 for the to store the input signal. Okay, because it will hold only arithmetic operation this thing, data.
okay,
Okay, this is a 1-bit memory. So here it is used only to store the input and output condition. Okay, whereas the D0 is used for arithmetic operation, especially for mathematical operations. Let's say you want to store the timer's elapsed time, or you want to store the counters counting, or let's say you want to add two numbers. Okay, so here in Omron PLC, whenever we are adding two numbers, we'll take two different data memory, okay, D0, D1 or anything, whichever you're convenient with. And we'll be giving values to D0 and D1 while we are running, okay?
okay,
Okay.
okay.
So any confusion in this?
No, ma'am.
Okay. So the next is set and reset, okay? Now, here, whenever we are using push button, we have to do latching, correct?
Yes.
I have to do latching, then I have to do again unlatching, or I have to go for memory address. So many things I need to use. Now in PLC, there is a one more option we'll get, that is nothing but set and reset. Okay.
Okay.
So 1 second, I'll take the. Can anyone tell me what is set and reset? What do you mean by set or reset?
When I press the button, the motor continues on. When I means it is set.
Okay, okay.
When I used another button for reset.
Whenever we use a set coil or a set state, so the output will remain always in a high state. Okay. So whenever I use a reset coil, the output will always remain in the 0 state. Okay. That is set and reset. Okay. So
Okay.
here always a set represents 1 and reset represent 0. Okay. Now, whenever we are using push button, I need to latch or then I have to use unlatch. So I'll be using multiple switches. Now again, we'll consider the motor operation only. Okay. Let's say I'm using one switch to on the motor, the other switch to off the motor. Okay. Now what I'll do, I'll take one push button. Okay. Now what I'll do, I'll not take this coil, okay? Neither this coil or this coil. I'll take a function block, okay? The set and reset here in the Omron will be in the function block, okay? This is a function block, okay? Now in this function block, you will be, the same function block you will be using for timers, counters, your comparators, your arithmetic operation, for every jump, subroutine, everything. This is the same block you will be selecting. Now, once you select it, click on details. Okay. Now, when you click on details, it will ask for find instruction. Now, here you will get various types of operation. Okay. Here, select sequence output. Okay. Now, here you can see set, set and reset. Okay. So now I'll select it set operation because I need to on it. Okay. Then it is asking for operand. So operand here is the name or address I have to give. So since I am using the output, I'll give the output address. Okay. So here it is showing Q0.0. That is nothing but our output. So I will write it as motor. Okay, now this is a motor. So next I'll use a reset because I need to make it off. So I'll be taking another push button. Again, select the function block, go to details, find instruction, sequence output, select reset. Then in the operand, give the address. Now here you can use the same address, okay? You'll be operating on the same output, okay? Now this is how we are using set and reset option. So now here you can see there is no need of doing latching or unlatching, okay? So you just need to use one switch to set it and another switch is for resetting. And here in this one, always a reset has a highest priority, okay? That means when you on both the set, when you make set and reset on at a time, it will give a highest priority to reset by making the output off. Okay.
Okay.
So we'll simulate it. So now initially these are in, I have made both the switches are in zero state, okay, and the output will be in the previous state, okay. In the previous whenever if I'm not taken a new project, I've just continued there, it will take the previous condition. Let's say in the previous condition, if this motor is on, when I run it, this will be in on state, okay. Now let me on it. When I on it, the motor is on, okay. Now I'll off it. So even if I make switch off, the output is in high state, okay. Now I'll reset it. So now this got off, okay. So I'll off the switch again. So this is how the set and reset operation is there, okay. So now one switch you'll be using it to make it on or to set it. The other switches you're using it for a reset operation. So this is nothing but a start button and this is a stop button. Now let me operate both the switches at a time. Okay, I will on both the switches. Now can anyone guess what will be the operation if I on both the switches at a time?
Both will
What
off.
happens? Output will be on or off?
Off, ma'am.
Yes, off, because the reset is given a highest priority, okay. So this, if you want, you can consider it as a, no, sorry, nothing. Okay. So here the priority will go up, based on that it will act, okay. So now reset is given a highest priority, therefore it will get off. If the set is given a highest priority, when both the switches are on, then the motor will remain on, okay. Got it? Any confusion in set and reset? Everyone?
No, ma'am.
Is it fine?
Madam, set how to configure, madam, that one more time show me, madam.
Okay, I will show once again. So now whenever you want to use set and reset, you cannot use this output coils, okay. Select the functional block, okay. It's our new PLC instruction. The shortcut is L, okay. Select this one and place it, okay. So now here I can, if you know the command directly mention set, then give the address. If you know it, if you don't know the command, then go to details. Then here in the details, you can go for find instruction, or you can select the instruction help. It will open the help page. There you can find the instruction, or go to find instruction. Here, select the output. Why output? Because you are operating on the output. You need to select the sequence output. There you can see there are different options are there. Go for set. Okay. Now select it. Then it will ask for operand. Okay. Now, if you are not getting what is operand, it is nothing but name or address. Okay. So on which address you are acting? You are acting on an output address. Give here the output address, whichever you are using. Then give OK. Got it? Now to select reset.
Ma'am, this one, ma'am.
ಯಾವುದು?
ಶಾರ್ಟ್ಕಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡೋದು ಹೇಳಿದ್ರೆ ಎಲ್ ಯೂಸ್ ಮಾಡೋದು.
ಅದು ಎಲ್ ಯೂಸ್ ಮಾಡೋದಾ? ಓಕೆ. Directly press L. If I press L, it will ask for load instruction. Okay, LD means load instruction. Sorry, wait. I think it is I. Okay. So I comes, okay. I means interlock. So this block is also called as interlock block. Okay, there you have to give a command. I'll give it as set. Okay, when I type set, it will come. Okay, select that. Now here it is popping the next address. I don't want next address. Select the same address. Okay. Okay, sorry, this should be reset. Okay, 1 second. Select this block, place it. Now, if you know the command, directly write set. Or if you know the command, directly write reset. Then mention the address. Okay.
Okay.
This is a shortcut one. If you don't know the command, you go for the details. Okay. Okay. Write a ladder logic to latch to output Q0 and Q1 with I0 and unlatch using I1. Okay.
Excuse me, ma'am.
Yes.
I have a small doubt about reset.
Reset. Tell me, what is the doubt?
Why you want to give the most preference of reset?
Why it is given a highest preference is that when you on both the switches, if there are it might get on or get off, or one more state is a toggling state. When you press two switches simultaneously, what happens? The output will be toggling, right? It will be like flickering. So it will affect the function of the system, or the output device. So let's say I have pressed both the switches at a time. The signal is going to the motor. If motor starts flickering, what happens? It will damage the motor, right?
Yeah, ma'am.
So therefore, whenever the two switches are operated, the off condition is given a highest priority. Okay, not the on condition also. It might also get affected. Therefore, the reset is given a highest priority to avoid the damages to the system. Okay.
Okay.